Okay, here we're going to use a special substitution to find the integral with respect to x of 1 over 36 plus 4x squared. So 1 that dx. So the first thing to look at is that we've got a common factor of 4 in the denominator. So I'm going to factorize that denominator and see if we can pull something out. So just rewrite this, so equals the integral of 1 over 4, or 4 nines are 36, 9 plus x squared dx. So what we can do then, we can pull a quarter out. You can always pull constants out of an integral and just multiply by them at the end. So if I do that, it'll look a lot nicer. So equals 1 quarter times the integral of 1 over 9 plus x squared with respect to x. Now, as far as the special substitution goes, if the thing you're trying to integrate, if it contains x squared plus a squared, where a is just some number, you should try substituting x equals a tan theta. So here, if you're looking at denominator, we have a 9 plus x squared, which is an x squared plus 9, which is the same as x squared plus 3 squared. So we do have our x squared plus a squared, x squared plus a squared, a is 3. So we're going to substitute x equals 3 tan theta. So that is what our substitution is going to be. So x equals 3 tan theta. Remember, whenever you're doing integration by substitution, you're going to have to replace the dx with something in terms of the thing you're making a substitution with. So a d theta, basically, something that has a d theta in it. So I'm going to do dx by d theta. Well, hopefully you know that tan theta differentiates to sec squared theta. If you didn't know that, then it's in the formula book anyway. So 3 tan theta is going to go to 3 sec squared theta. So dx is going to be 3 sec squared theta d theta. That's dx, which we're going to substitute when we transform the integral. So if this was the integral, so if I call this the integral, our transformed integral, so the new integral just transformed, now the integral equals, well, it's still 1 quarter times the integral of 1 over, and it's 9 plus x squared, so x is 3 tan theta, so it's 9 plus 3 tan theta squared, and it's dx, well, dx we just said is 3 sec squared theta d theta, sec squared theta d theta. So looking at that, there's nothing obviously that we can do. So it's some of these simple substitutions you can straight away just cancel things. There's nothing that we can do yet. The only thing I can do right now is expand that bracket, and hopefully it'll get to something that I can transform into a sec squared. So equals 1 quarter times the integral of 1 over, so it's 9 plus, well, 3 tan theta squared is 3 squared times tan theta squared. So it's 9 plus 9 tan squared theta. 3 sec squared theta d theta. So now when I look at this, I can see, just as when we started with the initial integral, I can see a common factor in the denominator. So what we're going to do, we're going to factorize that denominator. So new transformed integral equals 1 quarter, 1 over, I'm just going to pull a 9 out, so 9, 1 plus tan squared theta, times 3 sec squared theta d theta. Okay, I need a bracket there. Right, so now if you consult your formula booklet, there is a really helpful identity in the trigonometry section. So recall that 1 plus tan squared theta equals sec squared theta. So this is really handy right now because it's going to get us this sec squared theta that's going to cancel with that sec squared theta. So now our integral equals 1/4 times the integral of 1 over 9, and we've just said that 1 plus tan squared theta is sec squared theta, so 9 sec squared theta times 3 sec squared theta d theta. So now finally we're in a position where things are going to start nicely cancelling. So if you look at the 3 sec squared theta and the 9 sec squared theta, that will cancel to 1 over 3. Okay, so we now have 1/4 times the integral of 1/3 with respect to theta. I'm just going to pull the third out as well. So it's going to be 1/4 times 1/3 times the integral of there's just one left, 1 d theta. Well, it's a 1/12 on this side equals 1/12. And the integral of 1 with respect to theta is just theta plus the constant of integration. So that's not quite done because we need the things to be in terms of x, not theta. So now if we go back to our initial substitution, which was x equals 3 tan theta, so x equals 3 tan theta, so basically we just need to get theta in terms of x. So x over 3 must be tan theta, so theta must be the inverse tan of that, so arctan x over 3 must equal theta. So then I can just put that in here. So the final answer equals 1/12 arctan x over 3 plus the constant of integration is our final answer.